Now we're going to discuss the concept of end behavior of a graph. So the question you have to ask when you're talking about end behavior is, what happens to the graph of a polynomial when x is very large or very small? And when I say very small, I don't mean near zero. I mean x is a very large negative number, so negative 1,000,000. And here when I say x is very large, I'm saying when x is positive 1,000,000. In other words, if we look at a graph of a function, the end behavior, the concept of end behavior says, let's not look at the middle here. Let's only look at what's happening far away from the origin. So far to the right or far to the left. What's the function doing in that region? In other words, we know polynomials might have a bunch of zeros, but they only have finitely many zeros. In other words, a quadratic function has at most 2 zeros. But what happens when we get far away from those zeros? In this case, we have f of x equals x squared. It has only 1 zero at the origin. What happens when we go far to the right or far to the left so that we can even forget that this exists? We can forget that this is here and just say, what's happening to the function far away? Because we'll figure out the stuff in the middle later, but most of the graph is far away from the stuff in here. So we want to know what happens far away. And that is the concept of end behavior. What happens when x is large or very small? And the answer is the graph either increases or decreases for the entire time. Now this is very specific to a polynomial, but this is true of all polynomials. And so we can see these two examples, which will turn out to be sort of typical examples. So everything is sort of modeled on either x squared or x cubed. And I'll explain what that means later. But for now, we'll just look at x squared. So if we look away from this middle region and just look at what's happening out to the right or out to the left, we see that the graph increases to the right and increases to the left. In other words, that behavior on both sides is the same, and in this case it's increasing. Now, the way you could write that is as by either saying increases to the right and increases to the left, or rises to the right and rises to the left. And that's how you could describe the end behavior. Now, x cubed is different. It rises to the right, but falls to the left. In other words, it's increasing as we go to the right, but decreasing as we go to the left. And again, we're sort of ignoring this middle region, and we're just looking at what happens when x is very large or very small. So we can see that there's a difference between these two, because with x squared, the same behavior is happening on both sides. With x cubed, the behavior is opposite. On the right, it's rising, and on the left, it's falling. And it will turn out that if the highest power of your polynomial is an even exponent, like 2, 4, 6, then the end behavior will look something like x squared. And if your highest power appearing in your polynomial is an odd number, like 3, 5, 7, then your end behavior will look like x cubed and will be different on the two sides. But I'll explain that more in the next video.